In the previous video, I forgot to mention a really nice proof. I told you that there were two proofs that we were going to talk about for the harmonic series, and I forgot to mention the second one. So I wanted to go back and kind of fill this in. So we're looking at the harmonic series, which is 1 over n. This one goes from 1 to infinity. So that's, again, 1 plus a half plus a third plus a fourth. Okay, all the way out. I guess I better write some more terms, plus a fifth. And the first proof that we did involved using inequalities, which this proof will as well. But we looked at inequalities of larger and larger values. So we looked at the first 1, 2, 4 terms, and then we grouped them that way. What I want to do here is I actually want to look at grouping them in a slightly different way. So what I want to do is, let's say that the sum does converge. Let's say it converges to some value s. S is for sum. Then let's look at a few of these terms. Look at 1/3 plus 1/4. Okay, so look at 1/3 plus 1/4. What is that going to be? So 1/3 plus 1/4, it's actually the same inequality as before. We're going to get 1/2 plus, let's see, 1/3. So 1/4 plus 1/4 is 1/2. That's kind of the strange one. But if you look at 1/5 plus 1/6, that's at least as big as 1/6 plus 1/6. And 1/7 plus 1/8 is at least as big as 1/8 plus 1/8. And so on. And so what ends up happening is that you end up getting, I'm going to take this half that we got here and bring it out. But we got 1/2. And then look at the rest of these values. So we got 1/2. I'm sorry, 1, 1/2, 2 over 6. So that's 1/3. So we get the 1, just to make sure we're following here. 1, 1/2, this 1/2 I just put out front. This 1/6 plus 1/6 is 1/3. 1/8 plus 1/8 is 1/4. If you were to have a 1/9 plus 1/10, that would be greater than or equal to 1/10 plus 1/10, which is 1/5. And so it turns out what you have here is you have 1/2 plus the original series. So this is 1/2 plus s. And follow the chain that we have here. What we just showed is that s is greater than or equal to 1/2 plus s. That makes no sense. Okay, that's what's called a contradiction. We assumed for no good reason that the series converges. We saw that if the series converges, we get a problem. And so the only thing that we can conclude is, I guess, the series didn't converge. Okay, so the series is harmonic series. Okay, diverges. Now, having a value s that's greater than or equal to itself plus 1/2, that is possible if s is infinity. And that's basically what's going on, is that infinity is weird. If you have, say, infinitely many books, you can take the first page out of all of them and you can make a new book that's infinitely long. And so infinity has these kind of weird things that you can do with it. That's basically what's happening here. Okay, but I just thought that that was a nice second proof that the harmonic series diverges. So I wanted to share that.